Happy Monday morning. I know you guys thought I wasn't going to be here, but unfortunately you're going to have to listen to me for a little bit. I heard on Friday we had some trouble, so I figured I'd make a quick video and hopefully it'll help you guys out today. I'm not sure if there's a science teacher in the room with you or not. If there is, then you can ignore everything I'm saying, and if there isn't, hopefully this helps out. So you guys all have the PowerPoint of Unit 2. There's probably a couple extras in the room there if somebody somehow didn't get one, but we'll just quickly go through it. A lot of it's the same as what we did in Unit 1, so types of chemical reactions, balancing chemical reactions. They talk about combustions, oxides, and neutralization. This is the same as what we've talked about before. Just some terminology. We've got the reactants on this side, the products on this side. I don't think that's anything new. We've also discussed about the diatomic gases. Diatomic just means two, so these metals exist just by themselves, and I've mentioned that, and the nonmetals usually exist as a diatomic gas. So if you see chlorine or you're asked about Cl, you should assume it's Cl2. Now this is if it's a reactant. If it's a product, then you guys, there's another way to figure out what the products are, and we've walked through that, and I'll show you again here a little bit more. But if you see a reactant that's a non-metal, then you should probably assume it's going to be a diatomic gas. Sulfur here is S8 and phosphorus P4. You don't need to know that. Don't assume that. Just assume they're diatomic gases, and that'll get you going in the right direction. We have mentioned this already, 6 types of reactions, and you guys have done a little bit of work on that as well. The rest of this PowerPoint goes into breaking down what these types of reactions are and what to look for from them. You guys have that paper from Mr. Gooch as well that also tells you all of this stuff in other words, I guess. So if that doesn't work for you, you can look at this. If this doesn't work for you, look at that. First one is synthesis, so two things come together. Characterization, two things come together. Two things come together. Decomposition is the opposite. One thing breaks apart. One thing, two things. One thing, two things. Single displacement, one's going to come in and kick one out. So in this case here, I've got copper by itself. It's going to come in and bump silver out away from the nitrate. And so you get the silver now by itself, and the copper is with the nitrate there. So you got A plus a BC goes to B plus an AC. It's just one's bumping the other one out. Double displacement is the same thing. Now we've got two here. Okay, the potassium and the lead here are going to switch. So the lead goes with the iodine, and the potassium goes with the nitrate. There's your ABCD version of it. I'm going quickly because I believe this is a review for most people in the room because we did it in Unit 1. I'm going to stop here because we're not going to deal with acid-base neutralization very much. Okay, so you guys don't have to worry about that for today's lesson. We'll obviously move forward on that with the in the unit. We'll move forward to that. But the first thing you guys are going to work on today is just the types of reactions worksheet. So all the products and all the reactants and the products are given to you. You just have to simply write down what reaction it is and then balance it. Notice there's no numbers there. It's not balanced. Okay, there's 2 pages of that to do. All you're doing is writing a number in here. Okay, this reaction is complete, except it's not balanced, and we're just looking for what type of reaction it is. Once you're done that, then we're going to move on to the predicting reaction products worksheet here. So I know at the top here, I believe you guys have this from the other day already. So it was a little confusing to some of you, and maybe why is because it mentions here that some occur and some do not occur. We're just going to pretend like all of these occur. Some of them do not occur basically because of the activity series, or they're both soluble in water or something like that. We haven't touched on that yet, so not your concern right now. All I want you to do is pretend this reaction is going to take place and tell me what the products are, and then go ahead and balance it. So some things we're looking for right away. I see CH4. That's a hydrocarbon, and we've talked about that before, with oxygen. I've got something with oxygen. It's probably a combustion reaction. The second one here I will give you a more specific example of. Look, this is iron and hydroxide. That's your polyatomic ion. Okay, and then salt, sodium chloride. So if I'm going to write the products, or the products of that, I know that the iron here and the sodium here are just going to switch because it's a double displacement. Okay, so I'm going to have sodium come over here, so I'm going to have Na. It's going to get connected with the OH. Okay, now before I write it like that, I have to think about what is the common ion charge of sodium. Sodium has a common ion charge of 1, plus 1. Hydroxide, you guys have it in the handout that I gave you. The polyatomic ions are on there. And hydroxide is OH. I mean, otherwise you can look them up, right? If you don't know a polyatomic ion that's in class, go ahead and use your internet-connected device and look it up, right? If you're doing legitimate science work, it's okay. Hydroxide, OH, minus 1. So plus 1, minus 1, we just get NaOH. So that one's fairly straightforward. Now I've got the iron from the hydroxide coming over and bonding with the chlorine. So now I have Fe, and then I have Cl. The Cl is easy, because I know that Cl is minus 1. The Fe is has 2 different common ion charges. So I didn't tell you which one it was. Nobody told you here it was iron 2 or iron 3. Nobody said anything to you. But if you go back and look at the reactants, you see that there's an FeOH3. Where did that 3 come from? The 3 must have come from a positive ion charge in this particular iron of plus 3. So the plus 3 from there went down there, and the minus 1 of the OH went down there. Therefore, you get FeOH3. So this must be Fe3. It can't be Fe2. So now I have Fe3 and then a Cl minus 1. So the 3 from the Fe must transfer over to the Cl side, and therefore we get, if I do this right with a subscript, then we get FeCl3. Okay, so I've done that one for you. It's not balanced, but go ahead and balance it, and that one is done there. Okay, now this is one of the ones that actually does not take place, and we don't need to worry about why that is, but look, you can still go ahead and pretend like it does. You can balance it. It all works out great. Okay, if you look for some of the characteristics of the other questions, oxygen and a hydrocarbon. I wonder what that is. Okay, here we got one item going to what? Okay, so if you guys look through these, hopefully they're fairly straightforward, and you can work through those together. If you want to work with a partner or work with somebody else, that's fine, as long as you guys are making an attempt at this. I'm good with it, and obviously do what the classroom teacher tells you, but we'll see you tomorrow.